Hey team, today we're going to go through limiting reactants and stoichiometry. Now obviously you guys are already doing stoichiometry calculations, but in all the examples we've done so far, we essentially have not given two reactants for the chemical reaction. We've only given you one of those, and we've assumed we had plenty of the other one. Well, now we're going to go ahead and give you both of these, and one of these most likely will run out before the chemical reaction is complete. It's almost like making a sandwich. If you don't have enough slices of bread and plenty of meat, you'll end up with leftover meat but too few slices of bread. That would make you very sad. We're also trying something else new today. My hands, I've actually gone to a manicurist, and they look much better. We'll see how this works out. Okay, let's go ahead and begin. So for our chemical reaction today, we have a single replacement reaction where copper is going to be mixed into a solution of silver nitrate, and that silver nitrate will go through a single replacement reaction forming copper to nitrate, and solid silver will come out. And we've already got the balanced equation sitting there for you, and the two amounts of reactants given to you as well. And then on the right hand side, you'll see that what we're going to try and solve for is the mass of silver formed in grams from the 2 grams for reactants given to us. All right, let's go ahead and begin. And we'll start off, and if you look at this, the silver nitrate is much larger than the copper in terms of mass. So it may make you think, oh, I know what the limiting reactant is already, because there's more grams of silver nitrate than copper. But remember, grams will do nothing for you other than allow you to get to moles. That's where the true comparison begins. Okay, so let's go ahead and get started. And I think the best way of going through one of these chemical reactions, or limiting reactant calculations, is to take both reactants and turn those into the desired product in terms of the mole. So we're going to go from grams of copper over to moles of copper. So the molar mass from the periodic table is 63.546. And then we're going to go from moles of copper to moles of silver. And our balanced chemical ratio, for every 1 mole of copper, we're actually going to get 2 moles of silver. So there's where the stoichiometry step comes in. And then we're going to find out at this point how many moles of silver are formed. And if you do the calculations, you'll find you get 0.110 moles of silver based upon 3.50 grams of copper. Now, will we form that much? We don't really know. It depends upon our other reactant. So we're going to go ahead and take a look at the silver given to us, 10.3 grams of silver. And we're going to convert that actually over into the exact same product, which is moles of silver. So our molar mass of silver nitrate is 169.87 grams. And now I'm going to turn silver nitrate into moles of silver. And you can see that I've got a 2:2 ratio of silver nitrate to silver. So that's what's going to go into my conversion factor here. Now I could reduce that to a 1:1, but I really preferentially would like to see both of the numbers coming from the balanced equation. And if you do the calculation, you'll find that you only make 0.0606 moles of silver from the mass of silver nitrate given. Now once you've taken both reactants and turned those into product, you'll find that if you've hit the same product, which we did, one product makes more than the other. You can't make more than when one runs out. So obviously then our silver nitrate is going to be our limiting reactant because it limits the total amount of product that we form. This right here will be a question that we'll be asking you guys to solve for. What is the limiting reactant when given both reactants for a balanced chemical equation? So now we know that our limiting reactant will be the silver nitrate. Now this is a very important thing because every calculation that you now begin with will begin with that silver nitrate, which is your limiting reactant. And over here, the copper is now going to be called our excess reactant. We should have some of that left over. Again, it's like running out of bread. You'd have excess ham slices left over. So let's go ahead now and find out what mass of silver is actually formed. So to determine the mass of silver formed, we'll always begin with our limiting reactant. But we've already done that, so currently we've taken grams of silver nitrate over through the mole to the moles of silver. Now because I want mass of silver, I have one more step to do. So I'll go ahead and take that value and I'll turn that into grams of silver using the molar mass from the periodic table of silver. Now notice we are following sig figs as we go through these calculations. So anytime you stop in a calculation, it is best to go ahead and round appropriately. So if you do this calculation, you'll find that you'll form 6.54 grams of silver from the chemical reaction. And again, we're only using the limiting reactant to calculate this. So that would be a second answer that we'd be asking for on a quiz or a test. Now the last thing that we'll probably go ahead and want from you guys on this one is to find out what is the excess left over. Obviously our excess reactant is, from our balanced equation up here, copper. So what we now need to do is we need to find out how much of that copper is left over, because we know all of the silver nitrate will be consumed. So that would be a question that would be asked of you as well. How much excess reactant is left over? Now, the way that we can determine this is, once again, taking our limiting reactant, which we know is the silver nitrate, and we're going to turn that into the other reactant, which is copper. And you may think, well, I already know how much copper I have. Well, we're not finding out how much we have. We know how much we have. We're finding out how much we're going to consume. So that will be our next step right here. You'll always start with limiting reactant. And I would recommend going back to the original mass given to you. So we have 10.3 grams of silver nitrate, and we want to convert that from, once again, grams to moles of silver nitrate. Then once we get into the mole of the silver nitrate, we can use stoichiometry to convert that now over to the other reactant. So we can go from there over to the copper in terms of moles. And our balanced ratio, obviously, as you just saw, was a 2-to-1 ratio. 2 moles of AgNO3 for every 1 mole of Cu. Now I'm going to go ahead and turn this over into grams of Cu. And the molar mass of copper from the periodic table is 63.546. Obviously my units will all convert the way that they should, and I should end up with a gram of copper left over. So I have 1.93 grams of Cu. Now this is consumed. Should not have said left over there. That's consumed. So 1.93 grams of copper have been consumed. And I started with 3.50 grams of copper. So to find out how much excess is left over, I simply need to subtract the amount consumed that I just calculated from the amount given, which is 3.50 grams. This will tell me how much excess is left. So if I do my simple subtraction on this and I watch my significant figures, I end up with 1.57 grams of excess copper after the chemical reaction has come to its end. All right, so that is, in a nutshell, how you would go through limiting reactant and stoichiometry problems, finding out what your limiting is, determining the mass of product formed, and then coming back and finding out how much excess reactant is left over after the reaction ceases. I hope this has been helpful.